First of all, welcome to our second webinar of the year. This time we're going to be covering the use of artificial intelligence to improve student retention. So on the call today, you've got my colleague Dan Titchener, who is one of our Click consultants and a specialist in the AutoML area of the platform, and myself, Neil Thorne, I'm Head of Origination at Ometis. Now, in terms of agenda for today, I'm going to do a few introductions and then I'm going to position the product for you. And then we'll get into Dan doing the actual demonstration. I've put a Q&A session at the end, but please treat this as an open session and ask questions as we're going along using the Q&A facility. Now, if I think that those questions are appropriate, I will interrupt Dan during the demo. If I think it will interrupt the flow too much, then I will ask them at the end. But we will get to all of your questions. So yeah, please do ask them in that facility. Right. So I'm conscious that there's a few people on the call today who don't know who Ometis are, so I thought I'd just put up a single slide that explained who we are. So we are the UK's largest dedicated Click consultancy. We are an elite solution provider, which is the highest level that you can attain in the partner program. We are dedicated to Click platform. So we only do Click. Just over 25 staff and growing. We have customers in a whole range of different industries, but today we're going to try and focus on a specific use case in HE. I know we've got a lot of people on the call from other industries. You're more than welcome, and hopefully you can get some value from this as well. We offer a full range of services across the Click platform. You see them there: consultancy, development. We have a UK dedicated support centre where you can ring up and actually speak to one of my colleagues and they'll help you through any issues that you've got. We also have an education and learning centre which provides online classroom training, instructor-led training through an online platform. So it's been a while since some of you have been on these webinars, so I just thought I would put up the latest sort of version of the Click Cloud platform, where it's predominantly broken down into two areas: data integration and quality, of which we will be covering several elements of this on future webinars coming up, so please keep an eye out for those. Today we're focusing on an element that's within the analytics side of the platform. Many of you on the call are already using visualizations, dashboards. Some of you have got embedded analytics, and many of you are using the alerts that we talked about in a post that we put up earlier in the week. But today we're going to focus on what Click calls Click AutoML. So I'm going to take a step back and say, we just talk briefly about why do we think people should use artificial intelligence in the first place? And I beg your pardon, I've sorry, I pressed the button. Why we should use artificial intelligence in the first place? And there's no doubt that implementing an AI strategy does require some careful planning. However, we believe that the potential benefits for efficiency, data-driven decision-making, improved student service in this particular case that we're talking about, make it a compelling option for HE and FE organisations seeking to sort of optimise their operations for the future. And we'll cover elements of this as we go through the demonstration. Now, again, this is an area that Dan will cover in a little more detail, but I just wanted to put it up initially to explain that there are various levels of data analytics. So the simplest one is obviously descriptive. What has happened? and that can be a normal Click dashboard, it could be a spreadsheet, it could be a report. But the clever stuff comes in when we're talking about predictive. So what is likely to happen based on past results? And where Click comes into its own with AutoML is bringing in this diagnostic analytics, where we're explaining why that prediction is likely to happen. What are the key drivers behind it? And then also prescriptive. So what should we do next? Should we change policies? In this case, we're going to be talking about student retention. So should we be changing policies that will head off students who are likely to leave at the pass and make them stay on as students at our organisation? Especially relevant right now with the way that funding is being organised. So Click AutoML, what is it? Well, it's code-free experience, so it's drag and drop. As I said, it uses your historical data to generate predictive insights, and it does that by automating standard data science processes. So you can select the sort of best configured algorithms and models, and it will identify what the drivers have been behind that model choice and also give you an indication of its accuracy. So who is this aimed at, really? Well, power users that want to use Click's pre-built algorithms to build their own models and test hypotheses. Users, you do need to be data literate. We can't get away from that, but and understand the structure of your data. But you don't need that extra expertise of data science, and that's what this is all about, really. If you've got data science, one or two of you I know have got data scientists, sorry, then if they prefer to use R, Python, SageMaker, then of course they still can, and Click will integrate with those solutions. But why do we think this is important? Well, one of the key things is the speed of delivery. It is much faster than traditional machine learning because you have those pre-built algorithms where you can simply select them and then compare the different models that they would create. And that makes it far easier to productionize, if that's, I'm going to make up a word for the day, productionize the model. It's very quick then for you to create new deployments. It's an integral part of the Click platform. So, we will show it you just based in the Click platform. We don't have to go out elsewhere. And of course, because it's on Click Cloud, you leverage the whole of that cloud computing power. You don't need to maintain expensive infrastructure on premises. And apologies, a trite salesman comment, but it's data science for everyone. Make that ability available to the wider organization and the whole of your data community. And what do I mean by that? Well, data scientists are expensive people. They, it's a complex, sort of task in its own right. And so, if you were to set people, what will student grades be next term? Well, that would take some time, I would suggest, to create that model and bring in all the different data. And so what we believe you get from ClickML is that you can answer not only that question, but a whole raft of other questions. And that, this isn't a limit, it's just an example of some of the things that you can do. And we will, Dan is going to cover elements of those questions in his demonstration coming up. So the demonstration itself, what we're going to do, the scenario we're looking at for this is reducing student dropouts, how we can maintain that level of retention. And I think what I will do now is hand over to Dan and go from there.
Thank you very much, Neil. Yes, so just to take you through today's demonstration. So as Neil says, the topic, the data topic that we're going to use as an example, is a data set that shows student information, so information about each student, like whether they attended lectures, what degree subject they're doing, what their bursary amount is, and whether they dropped out in the past. And we're going to use that past data set as our starting point. And I'm going to show you two things. I'm going to show you a walkthrough of how we create a model in the first place, and what the options and how it feels to go through that process, how quick it is, and how we deploy that and create a prediction. That's the first step. And then the second step is really to show you what you can do in ClickSense using AutoML, and how we really can sort of leverage that, the power of that analytics, and how we can take you beyond, what is predicted, and I'll show you how AutoML takes you to the next step. So without further ado, and I'm going to refer to those types of analytics you saw before. So without further ado, I'm going to share my screen. Okay, and so, right, so as a walkthrough of creating and deploying a model, I'm going to first create a machine learning experiment in ClickCloud. And this is going to be a container where I configure the model. So I'll just give it a name so I can find it. Here we go. So, and then we get into this screen. So it walks you through step by step, and I'll show you how easy it is. So first thing we do is we choose our training data set. This is data, so in our example, you'll have information from past terms. So you'll know information about the students, and you'll know whether they dropped out or not. And you'll have information about, whether they attended lectures, what their degree subject is. And so that really is our training data set. So I'm going to select that past data now. And so what the screen is it profiles the data, shows you the information about each student. So this is showing you all the information you've got in that data. So you've got things like age, distance from home, whether they dropped out, bursary amount, all of this. You can see sample values, so you can check whether there's any issues with the data. It will profile it for you. And so this first screen is asking you to specify the target that you want your experiment to predict. So obviously you could select anything, but what you really want to do, what we're trying to do is predict who's going to drop out. So that's my target, whether they dropped out or not. And obviously this is a yes/no type question, right? So so keep that in mind. So whether they dropped out or not. But when I selected dropped out, you will notice that most of the features are ticked here, but student ID wasn't picked. So what AutoML has done is it said that throughout the data, it's identified things that it doesn't think are actually going to be useful at all. So don't even bother putting that in your model. And it said that student ID is one of those fields. So there's really no benefit in actually having that in your model. It doesn't tell you anything in and of itself. And at this screen, I have the opportunity to say, well, do I want all of these to impact my model, or do I actually want to choose to not include some of these? And you could, choose to say, I don't want marital status or age or any of this to influence the model. I just simply deselect them at this stage, or I can do it later as well. But you have that option. And on the right-hand side, it gives you a breakdown of the configuration of the experiment. So, and if I expand some of these options, it shows that I've selected that as my target, and then it gives me a list of the features that I've selected. It said I've selected 20 of the 21. If I, for example, said I don't want marital status in there, then it shows, obviously we're 19 or 21 now, and it shows which ones you've deselected. The next part of it is it says this is the algorithms drop down. So remember when I said dropped out is a yes or no problem? So actually what it's recognized here automatically is it's recognized the type of problem that AutoML is being asked to look at here, which is a binary classification question. So yes, no. And what it's done is it's recommended 8 algorithms that are suitable for that question. And I won't delve into the detail, but just for those technical elements, you can choose to not, you can opt out of some of these algorithms if you like, but you have 8 to choose from. And for the, I want everyone at this point to appreciate that none of this needs to be coded by you. This is pre-coded by Click. So these are ready to go solutions. So those are my algorithms there. So I'm ready to use them. And so the green button at the bottom, I will now run my experiment.
What is going? We've had a quick question, which is how did we create the QVD of the past data set and get it into ClickSense?
Yeah, great question. So you may have to join, for example, you might have a data set which has lecture attendance, and you might have a data set which has list of student by subject, and you might have a tutor data set. What you would have to do is to prepare that beforehand. So you would have to join this information together to have a flat file, a file that has everything. So a line per student and all of the information in one row for this particular question, for example. Were there any?
No, that's the only one so far.
Yep. Okay. Yep. And if you had if there's a follow-up, just put it in the chat and we can answer it later. Okay. So what this has done is it's assessed how well each of those 8 algorithms has done using that training data. So what it does is it withholds some of the training data each time and assess whether the remaining part successfully predicts the bit that's missing, and it keeps doing that to check to check its theories each time, and it tweaks its parameters so that the algorithm performance gets better over time, and it just carries on like that. And it's actually assessed that one of these algorithms is the best performer. This F1 score, I'm not going to delve into the details, but it's at the overall score of how good the model is. And then there's other scores here. What they're really doing is it's saying things like, does it successfully identify the dropouters? And then there's other scores that says things like, does it successfully identify those that are not going to drop out? So they're subtly different things, because you could say everyone's likely to drop out, and then you'll be 100% identifying the people who are going to drop out at the expense of identifying completely missing the people who aren't going to drop out. So both are important, and that's what those scores are capturing. Depending on your problem, one of them might be more important or less important. But overall, this top algorithm here is that one there, elastic net regression. Importantly, on this page, it shows how significant each of these features are to the model. And if we scroll down to the bottom, for example, it's showing that degree subject isn't that important, and neither is age. And what you can do is you can configure this again and say, actually, I don't want to include some of these features in my model. And if you do that repeatedly, the model performance will get better over time. So this is where iterating the model really helps. So you don't just deploy the first version, you make slight tweaks to it as you progress through the process. And you might even, oh, yes, please.
That's right. Yeah, another question that I think is probably linked to this bit that you're talking about now. Yeah. Gordon's saying, can I raise the weight of a particular input? So say it from experience, age was very correlated to the dropout rate.
Not really in terms of this. You can't directly change it. What you can do is review the models and select the model which has where age does in fact have the most importance. So you can choose a different model, for example, number 3 here, and you might see that age is, this age in this model is higher, and it has a slightly less accurate rating overall, but actually it might have a better performance than some of the other categories. So yes, you can select you select a different model with a different performance and importance to a particular feature. Yeah, great question. Was there any more, Neil?
No, that's it.
Okay, right. So what we will do then is I will just show you the experience of deploying one. So I'm going to create a new deployment. Okay. And what this will do is this takes us away from the experiment to a deployment. And what a deployment is it's an area where you can create a prediction with new data. So what I will do, if I stop for a second, the new data would be your data for this term, for example. So if I create a prediction, I select my apply data, which will be data for this term. And obviously, what the requirements on the apply data is it has to have the information that your model uses, right? So your model has these features, the ones you selected, for example, age, if it's a really significant feature, it's obviously you're going to need it in your apply data as well. And so everything seems to line up here, so that's great. And I'll name my prediction, new prediction for this term. Create that there. And then you can decide whether you want to have the SHAP data as well and the errors data. I will select that. And you can also schedule this. This is how easy it is to create a new deployment. So and productionize. So you can create a prediction at whatever cadence you want to. I'm just going to create a one-off prediction now, but if you wanted to, this could run many times, like every week or something, and you'll see how the predictions change as the input data changes. But I'll save and predict. What this is doing at the moment is it's using your new data combined with the model to create a prediction, and that will only take a couple of seconds. There we go. So look how fast that was, no coding or anything. So if I open that, excellent. So we've got new prediction for this term a few seconds ago. So what I can do is simply open this. So this is a standard QVD, nothing special about it, but this is how it integrates with the rest of the platform, right? So this is it creates a data set, and you obviously you've got things like student ID, but the one we really care about here is it's showing you straight away this model is predicting 41 students will drop out, the ones there, and of the remaining 242 that aren't predicted. So that's how quick it is to get a prediction, right? And I can create an app on top of this using a data set, and that's the experience there. And this is exactly the same as creating a normal QVD. Okay. So this is really answering that. This is that second type of analytics. What is likely to happen? And I can, so quickly say, how many students are likely to drop out. If I ask that question, it's going to look at that QVD to see if it can answer the question. So it's actually here, this bar chart here. It's created a count of the number that are predicted to leave or stay. So that's really how quickly it is. Obviously, so the second part of the demo is to extend this, and I want to show you what you can do with this data. So this is a pre-prepared demo, going through the same process, but using Click to its fullest extent with AutoML to show you how we can, go beyond what is likely to happen, the predictive part that Neil showed you, to not diagnostic, You know, why is it likely to happen? Why is it likely to happen? And then even the what if analysis. So without further ado, I want to show you how we can show the predictive part, what is likely to happen. So, okay, so what we can do is, here is a chart which shows you who's predicted to leave, their name, and the likelihood of them leaving. So this model's chosen a particular threshold above which it's saying, I think this person will leave. So this is all of the possible leavers, the predicted people. I think it's 41. It will differ depending on the model and how you've configured it. So at the top here, Mohammed is predicted to have the highest likelihood of leaving, and Ollie and Elijah are very high as well. And as we scroll down, it's sorted in such a way that down the bottom, there are people very close to that threshold, just above the threshold. I think it's a useful insight to know it's not just a yes or no, the prediction. It's saying, you know, I think these are very likely, and then other people are less likely. But that's the simplest question, like what is likely to happen. Where AutoML really comes in, and you can do this in other. You don't have to use AutoML for this question, but it's so quick to do it in this way, and I'll show you, like, we can take this to the next level. So why is it likely to happen? This is where it really gets in. I'll show you the power of this. So, right. So there's two different lenses we can look at. We can say we can take a step back and look at the whole population, and we can look at the individual too. Let's take a step back first. So this page, what this is showing you on the left here is the top leaving factors per student. So in our data, and it's not real data, just so you know, but in our data, it's identifying the top leaving factors. So, for example, 74 of the students, the biggest push factor, and there'll be things actually the other way, like things making them want to stay, but the things pushing them away, and in some cases not far enough, so they are still wanting to stay. But 74 people, the biggest reason why they want to leave is lecture attendance. And you can see, obviously, last exam result is a big factor, teaching satisfaction. And as we go down, in this model, not real data, age is not as important, but obviously your subject matter experts will know that in reality, these features will be in a different order. But in this particular example, degree subjects is not that important. Year of current degree is not that important. So it's taken a step back. Why are people predicted to leave? And I've highlighted here the values in the field, the important fields, like living arrangement is important, has a big reason why people are leaving, but it's a particular value of living arrangement, particular option. It's people who live at home, in this example, have a higher likelihood to leave. And also lecture attendance, a bit of a no-brainer, but if they're not attending over 90%, then this model is saying it's far likely that they're going to leave. And tutors is another interesting example, because in this simulated data, you can see that actually some tutors, their students are very likely to want to leave, and then other tutors is the opposite case. So yeah, that's the kind of the population view. Why are people wanting to leave, and delving into a bit of detail. But we can also look at the individual student. Why are they likely to leave? So if we do that, so let's have a look. So if I look at Chester, kind of in the middle of the likelihood range. Okay, so if we look at Chester, okay, you can see that their lecture attendance is over 90. So this is all of their data, and it's showing that lecture attendance is the biggest push factor, and also degree subject, the fact that they're doing business is a bit of a factor as well, and also living arrangement. So it's actually showing that there are individual reasons why some students are predicted to want to leave. And also, if I change that to someone else, like Alfie, it changes per student. So actually, Alfie, the reason they want to leave is distance from home. And because that number is very high compared to other, it's very high in the range and affected by teaching strikes. So yeah, so that is kind of the individual why, explaining the reason behind a prediction. But let's now look at the final type of analytics that Neil showed you, which is the prescriptive part. Like, what can we do, right? So we've got reasons why people want to leave. We know what the predictions are, but what can we do? This is where I think AutoML is particularly great. So let's have a look at, so there's two lenses we can do. We can take a step back and look at the whole population of students, or we can have a look at the individual. In each case, we're going to change the input data and see what the output, the output would be. And it's completely interactive. So what we've done here, and you can do this yourself. So it'll be different for each use case. But what I've done is I've prepared certain policies, options, and like dials that you could change. So if I think of like a department or a top level student administration, if they had a remit over a whole population of students. So what they, and I prepared some options here, and what this will show you is the effect on the number of students predicted to leave. So actually in this model, it's actually 44 is the number there. So if I change nothing, there's no effect. Let's imagine we have a simple policy where we're saying, what have we said? Every student has to have a check-in every week. And so this is going to affect students which aren't coming in very often, but it won't affect students who are, because they are already coming in. Right? So if I introduce that policy, you can see that actually it's saying, oh, the effect is that we predict that 2 people now want to stay. So actually we've had a small beneficial effect from this policy. But what if we want to, have a better policy? There must be a better policy out there. So AutoML, we can overlay lots of these options at once. So we can explore what happens if we make a slightly more complicated policy. What if we say weekly student check-ins, and let's make lecture policy mandatory? So if we do that, you can see that is a marked increase in the speed. So we can actually see that a marked increase in the effect of the policy, I should say, sorry. Actually now 60% of the predicted dropouts are actually, we're predicting that they will now want to stay if this was put in place. And you can see who they are. So Frederick and Heidi and Eleanor. And you can see the changes introduced by the policy. So you can see that some people, it's the fact that their days since the last sign-in has reduced. And you can see that their lecture attendance has all gone from no to yes, as over 90%, because that's a blanket policy. And yes, so you can see that policy is a lot better. And there's I made some slightly more complicated policies. So I said, for example, what if struggling students go to student accommodation? That's a slightly more complicated policy, because it doesn't affect every student. It only affects students who have accommodation, student accommodation, and living arrangements as a reason for wanting to leave. But that's just to show you that, yeah, you can be really creative on policies. You can be more, you can have some more simpler policies, but that's really open to the developer. But that's really a powerful tool. But obviously, it's not the whole factor, because you've got 17 students here that are unaffected by the policy. There's still 17 people who are predicted to want to leave. So what can we do to reach them? That's where the individual what if analysis. The individual kind of prescriptive analytics can come in and have a really good effect. So I'll show you that. So that's where we go back to the individual insights page again. Let's have a look at Michael. So individual factors here. So Michael, living arrangement is a push factor. The biggest, strongest one here in the deepest red is lecture attendance. Right. If we click this button, what this is showing you is bringing this into life a little bit. So it's showing you the current situation, like bursary at 400, days since contact with student 2 days, lecture attendance is not one of the people who attends over 90%. That's their tutor, that's the living arrangement. And on the right here is where the dial is for Michael. So he was roughly halfway through the sorted list there. He's sort of like he's moderately likely to leave, but he's not all the way to 100% there, right? So and what we can see here, the green parts of the chart are options where if we chose that option, if we tweaked Michael's situation, that would actually have a beneficial effect to the extent that he would be likely to predicted to want to stay. So if you look here for living arrangement, actually student accommodation is one option that would actually convince him to stay, predicted by the model. This isn't 100% certain, but this model is saying that. So if I first select hybrid, this red bar, it's not enough. We're still in the red, but we've improved the situation. But if we go one step further and say student accommodation, we're now in the green. And now you can see that actually that's good enough for Michael to be overall predicted to want to stay, just changing the living arrangement. But we have another option. We don't have to do that. We could actually leave the living arrangement alone and say lecture attendance. If we just do that, make it mandatory. If Michael attended lectures, then that's enough, again, for Michael to want to stay. So those are options for Michael, and each student will be different here. For example, let's have a look at Elijah. So Elijah will be different. So you can see his lecture attendance, last exam result here, and living arrangement. So you might have been wondering why didn't I put all of the features here? Well, not all of them can actually be changed. So in your what if analysis, is things that you have direct control of, would make sense to put not direct control or recommend something you can recommend to the student, I should say. But yes, that's the situation. So if we have a look at Elijah, for example, this is Elijah's situation. So we're in a field of red here, and you can see that the dial is more further into the red. So this is saying that actually we've got some more work to do, and actually no single action is enough to convince Elijah to stay. But what if we say, let's say student accommodation. So now you can see that the dial is now closer to the green. We've improved the situation, but he's still predicted to leave. And then you can now see, obviously, that now lecture attendance is enough. So it's saying that living arrangement, and if we now make lecture attendance over 90%, then those two things in combination is enough, whereas one wasn't. So this is a different situation to the other individual there. So this is giving you a specific recommendation for each individual student. And there's nuance here, right? So it's showing you that actually most tutors would be fine, but if Elijah's tutor changed, then actually that would push it back into the red again. So that's a little bit of nuance there. Yeah, there we go. So Oh, did we have a question?
Been asked a question. Yeah.
Please.
So Dawn's asking, how do you set up the change policies and their potential impact?
Yeah, great question. So how you do that is there's a I won't go into too much detail of but there's a function which basically makes a call to the prediction and what you do is you supply the input data. So if you do nothing and just set it up kind of in the current setting, the answer it will give you will be the current prediction. But what you can do in the arguments, the parameters of the function there, is you can say, instead of saying whatever the lecture attendance was in the data, if you set it to yes, as in yes, that they all, you're basically hard coding, yes, they all attend over 90%, literally by typing in yes in the function, then that's basically effectively introducing a policy that they all attend lectures, and that's how you do it. And what you do is you can set up as many kind of interactive aspects as you like. I set up these policies. So, for example, living arrangements, strugglers to accommodation. What this does is it in the function, there's a kind of an if, there's a conditional bit in there which only changes students that are struggling. So it's not a hard-coded yes, it depends on the student. And you basically put that in the function, and the output is the new prediction.
I guess they're going to be different for every company, aren't they, or organisation?
Yeah.
Our aim mainly of today is to give you a flavour that you think, yes, we'd like to explore this further, and then we can delve deeper into those sorts of questions, Dawn, as well.
So yes, that brings me to the end of the demo. I don't know, Neil, if you're able to bring up this kind of the summary slide.
Yeah, sure.
Excellent, thank you. So yeah, just to recap then, because that was a lot of content. So just to take you through what we looked at then. So we didn't go into the descriptive really, because that first type of analytics, because that's really what ClickSense alone is just a great tool for, looking back at data, slicing, dicing, giving you insights. But you saw how quickly it is to generate predictions. You know, that's a very, you know, sleek, intuitive process to create that that prediction, that the simple yes, no, and what is the prediction. And you saw that you even get the likelihood of someone leaving, and you can rank them like that. I showed you how far they were into the threshold, that bar chart. But then I showed you that you know, how easy it is and how brilliant Click AutoML can cover those last types of analytics, right? Why is it likely to happen? I showed you that you can look at the population and see what their top leaving factors are, and you saw it was lecture attendance was the top one there. And you saw some things actually don't have weren't the top factor, but then you saw that there were two lenses there. You saw the individual explainability as well. You saw why specific students are wanting to leave, and coloured in red, right? So you saw that some students, it was actually the distance from home, for example. And then the final part there, the prescriptive, that's really the value add for me. That's like, what can we do? So you can you saw how you can create policies and see what the effect would be, and how that would affect the population of students and the overall dropout rates. But you saw that also you can do that at an individual level, maybe a different use case for a different team. And you can see how tweaking dials for individual struggling students you could see what are the changes that you could do to improve their situation. So yes, that brings me to the end of the demonstration. Yes, thank you, Neil.
So we've got a Q&A session. Obviously, we've covered off a few during the webinar, but I have got another one. So Ken has written, what if you want to use another algorithm, like a simple correlation?
Yeah, so Click has these 8 selected algorithms for that type of problem. So you can really only use the ones out of the box. But what I will say is Click is fantastic around if there's another algorithm. You know, we have the relationship at Ometis. We can talk to Click and make suggestions about the product. And if there's a clear demand from users for different types of algorithms, I'm sure that's something we can pass on as something that businesses are looking out for.
Okay.
But yeah, you're limited to those 8.
And then Gordon asked earlier on, if we have very granular data, will it create discrete buckets for prediction? So for age, rather than 32, it would be in the 30 to 40 bucket, or does that have to be done in the QVD up front?
Yes. So what you would do is you would prepare the data. So so if you had really fine level data, you would aggregate it to the appropriate level. So that would make sense for your prediction and your model. But for age ranges, yes, you probably, I think you should prepare that data first before you create the model.
Yeah. And then my expertise is limited, but it sounds like section access to me. Ethan has asked, is there any ability to, once the data is analysed, provide access to students based on roles, or is this mainly a tool used by someone who has access to all students? He put, I ask because we don't have that role in the university. Each school has a specific role that looks at the students related to that school. So I think this is, use of the app after the event, isn't it? And then using section access to restrict who can look at what.
Exactly, you're exactly right. Yes, so I think it depends on whether. So the interactive part, the prediction and individual students' prediction that would be a section access use case. Indeed,
So sorry, for Ethan's benefit there, I can see where he's from, and he's not a current user of Click.
Okay.
So that's a piece of function, Ethan, that's just built into the product. It's a very common use case to restrict who can see which bits.
John, just to expand on that, for example, if you had department data, you could set it so that only people in that department would see the data for that department. So if it was like a department faculty wanted to see predictions for their department, but you didn't want every people from, you wouldn't want them to be able to see data for other departments, then that could be something arranged. That's as Neil says, that's the section access. Many wide applications.
And there's other ways we can do that as well in terms of anonymizing, isn't there? I remember, I think it was John Lumley at the data conference that we held. He was showing how his university compared to others without naming who they were, so you could see yourselves and where you were in the data with it compared to everybody else, but you couldn't see who they were. So there's elements of that. I know John's asked a question actually. Is it possible to see the effect of a policy change on students not originally highlighted? Some will be for individual students moving into accommodation, etc. But the policy of making attendance mandatory would have to be applied across all students. this could have an unintended consequence for someone who wasn't predicted to leave originally.
Yeah. Yes. So you're absolutely right, and it just so happened that the policy examples I showed did only had a positive effect. But what I could have shown you, and I'm happy to provide that example later, but that is set up to show now wants to stay, as in new good changes, but also now wants to leave. So it's showing good and bad effects of the policy. Yeah. So it's assessing the entire cohort of your applied data set. Yeah.
Yeah.
Not just the leavers. Yeah.
Well, that's fair enough. I think we've finally run out of questions, unless anybody wants to jump in quickly. So, why can't I move that on? Sorry, bear with me just 1 second. I'm just trying to move the slide on. Oh, there we go. So in terms of next steps, I hope that's been of use to you. As I said earlier, we're trying to sort of set the scene. So if you want to go into it in more detail, then please do get in touch. Even if that's, some of you may want to do some sort of proof of concept of it, we're more than happy to get involved there. But we also do regular blogs, so please read our blog. Okay, I haven't overtyped that. So read our blog on this subject, which I will be sending out these slides and a recording anyway, so you'll be able to click on the correct link there. You can also watch our previous webinars on the YouTube channel, so yeah, please do that. And then that fourth one, I come up every time. Please let us know if you've got other topics you'd like us to cover, and we'll do what we can to accommodate you. The best place to follow us is on LinkedIn for the up-to-date announcements. We do all sorts on there in terms of blogging or sharing other people's posts. And our next webinars, these are going to be, we hope, every couple of weeks. And our next one at the end of in fact, next week is 30th of March, let's just say 30th of January, apologies. That's right back facilities. So if you've got a requirement where you want to change data on the face of your dashboard, then please do attend that one. But other than that, I hope you've all got some value from that, and we look forward to seeing you on the later webinars. Thanks very much for attending.